common understanding on this, then the lyrics and the institutions can't be built effectively. And that's how ESCO is pursuing this, again, with the League of Arab States and ACSED and our partners, both in the Mashriq and the Maghreb region, to push this forward. And on pollution, water quality will be one of those stories. It's on the shallow aquifer systems. It's also increasingly problematic as we think of disaster risk, the flooding, and what's happening on solutions. Some people in the Gulf, some countries have been considering about groundwater recharge, but they tend to use desalinated water. But now with all the floods and the intensive rain events we're witnessing with climate change, there might be other opportunities there, but we have to make sure that those strategic resources, those strategic shared groundwater resources are clean, again, for current use and that of future generations in an SDG context. Thank you.
Yeah, many thanks, Karen. So I'm conscious we have actually reached the end of this panel session. So I would really like to thank the panelists. Thank you very much. I would like to thank the participants, and of course I would like to thank UNESCO for hosting it. Please do join all the other sessions at ESAN. And now we'll hand the floor back to Alicia. Thank you.
Thank you very much, Federico, and thank you all. The last words from Carol were about capacity development and no cooperation, no hydro diplomacy can work without the countries agreeing on a conceptual model, I mean, on the data they have and sharing data on transboundary aquifers. And I'm very pleased to have Conchita here with us because, as Federico said, the accelerator on capacity development is one of the crucial accelerator of the global accelerator framework. And we would like to thank you very much, Spain, for accompanying UN Water in the new initiative on capacity development. And we should all pay a toast to UN Water for having coordinated and continue to coordinate the SDG 6 mechanism of monitoring. And with this, I thank you all again. Thank you very much.
Thank you.
Thank you.
Thank you. Bye.
Bye. Thank you.
Thank you.
Thank you.
Bye-bye.
All the participants, just a quick note to remind you that the session number 3 will be starting immediately. So if you wish to attend that session, you need to navigate on the Hoover platform to attend session number 3 on the Transboundary Aquifers contributions to the SDGs. On this room in 15 minutes, we will be starting session number 4, so you can stay connected if you wish to attend that one. Session number 4 is also on Transboundary Aquifers contributions to the SDGs. Thank you so much. Have a nice day. Good morning, Matt Erickson. Are you connected? I see that you're connected as an attendee. I promoted you as a panelist. Can you please accept? Thank you.
Yes, I'm here. Thank you.
Great. Good morning.
Good morning.
Okay, sound and video are great, so let's just wait. Thank you so much. Good morning, Raya.
Good morning. Can you hear me well?
Perfectly. Thank you so much.
Can I try just to share my screen for 1 minute just to see if it works well?
Sure, go ahead.
Okay, let me prepare my presentation.
Rita, is there an option to change the background?
Yes, you would need to do it yourself. There's a small arrow in your video.
In the video?
In the bottom of your screen, you see stop video on the left side, and there's an arrow pointing up.
Yes.
Okay. And there should be an option for choose the background, choose virtual background.
I don't have that. It says select the camera only.
Oh, okay.
So maybe that's...
That was the reason panel two session that I'm sharing.
Rita, can you see my presentation well?
It's perfect. It's perfect. Thank you.
Okay. Okay, I'll stop the sharing now.
Okay. Hello, Zaishing.
Nice to meet you.
Hello.
Hello, how are you?
Hello. Nice to see you. I'm in the evening.
Hi. Just to make sure the video. Okay, good.
Okay.
Good morning, Abdu. Can we have a quick sound check? Hi, Abdu. Can you say a few words, please?
Yeah.
Hello.
Hello.
Abdu, I think you are muted. You need to unmute yourself. Okay, can you try now?
Yes. Bonjour. Bonjour tout le monde.
Bonjour. Merci beaucoup.
Bonjour. Merci.
So I just want to let all our panelists know that there is interpretation services. So you can have the interpretation icon from the bottom bar. You click on the interpretation and choose any channel that you want to choose. So you can hear like the English channel or the French channel. And also for the French speakers, you can choose the French channel as well.
Bonjour tout le monde. Si vous avez besoin d'une interprétation en anglais, vous pouvez appuyer sur le petit globe qui se trouve en bas de la barre à droite. Vous appuyez sur interprétation et vous pouvez choisir le mode anglais.
Ou français.
Ou français.
is in a large part of it is in the transboundary aquifers. So this is something that we really need to highlight more and better in the future. So we have 5 distinguished speakers in this session and 1 pre-recorded video message to show in the end. And after the presentations, which are 15 minutes, we will have space for some discussions and dialogues, hopefully. And if you're in the audience and you want to have questions, I suggest that you use the Q&A section or the chat to send your questions, and we'll see how we can pick them up. So I'd like to introduce the first speaker, which will be Dr. Alfonso Rivera, and speaking about the evolution and success of ISARM in the decade 2010 to 2020, which is a very timely topic, of course. Alfonso Rivera is for the former chief hydrogeologist of the Geological Survey of Canada. So he has an enormous experience and have practiced hydrogeology for more than 40 years around the world. He has been playing an important role in ISARM and also led the group of 24 countries to prepare the regional strategy for evaluation and management of transboundary aquifers in the Americas. So I'd like to give the floor to Alfonso, please. We look forward to your presentation.
I'm sharing. Okay. Well, thank you so much, Mr. Erickson, for this introduction. And good morning, ladies and gentlemen, and good afternoon in some places. All right, so my talk today is on the evolution and success of ISARM, and I'd like to acknowledge my co-authors, Christina Fraser from IGRAC and Alicia Aureli, who you all know, and UNESCO. This is a slightly different talk from the one I gave yesterday, but some of the slides are the same because it's worth repeating. It's a keynote thing about ISARM, having the perspective of what's happening, and also a little bit of some of the data and information that we are still required to acquire. So what I'll do is I'll present. Sorry, it doesn't go forward. Just here, okay. Yes, I covered my topic in these 4 themes. I will provide an introduction, particularly concentrating in the main outcomes and outputs of ISARM. And then I'll show you a little bit of progress on the transboundary aquifer assessment. What's important to keep in this theme is these 3 items: the cooperation, the collaboration, and the hydrodiplomacy, which is a very high degree of getting together for doing the transboundary aquifers. I will then go on and describe the role of ISARM and the influence of ISARM actually on the Sustainable Development Goals, particularly the indicator 5.6.2, and summarize. So here we go. The internationally shared Aquifer Resources Management Program was launched in June 2000 at the 14th session of the Intergovernmental Council of the UNESCO International Hydrology Program. The first decade of ISARM culminated in a major international conference in 2010, right exactly here where we are sitting today. And 11 years after that significant conference, this is actually the second decadal conference in 2021. Main outputs and outcomes, after 2000 year ISARM created, immediately following that, a framework document to frame actually the program was published by UNESCO in 2001. And then a bunch of people, mostly hydrologists and lawyers, got together, put efforts to generate these draft articles of the law on transboundary aquifers, and I'm sure you will hear a lot about them in the coming days, in 2008. Right after that, the first atlas of the transboundary aquifers was published in 2009. And then is the conference I was referring to in my first slide, the ISARM 2010 First International Conference. Following that, a series of activities and products appear, one after the other. First, TWAP, which I'll talk about it in a minute. The GGRETA project in 2013 is still going on today. And then the World Transboundary Aquifers map produced by UNESCO and IGRAC in 2015. And as you know, we'll have another one and this week. The ISARM Americas strategy was published in 2015. And then there was a special issue with 12 high-class scientific papers in 2018. Most recently, which is one of the topic this morning, is the Sustainable Development Goal 6 and the influence of ISARM and Indicator C52 in 2 reports. And here we are today. This is the second conference, 2021. But I dare to show already not only progress in the past, but also coming on in the future. So we have a chapter on transboundary aquifer that will be published within the United Nations Water World Development Report next year in 2022. And then we have, as you probably already know, the big year of groundwater, making the invisible visible. Will culminate in the Groundwater Summit, also, I believe, in UNESCO in 2022. And we will have a book compiling the best, or the selected abstracts and papers from this conference into a book. So there you have it. Those are the main things in less than 2 minutes. Now, let me tell you about the progress, which I also presented yesterday. Now, once again, this data and information I'm presenting here obviously will be updated following this conference of this week. Here, what I'm showing is a snapshot as per 2018 with the regions having ISARM networks: Africa, Americas, Asia, and Europe. In Africa, up to 2018, 72 transboundary aquifers were identified, some of them mapped. And there were 2 political agreements and some international scientific arrangements. The ISARM Americas group identified 74 transboundary aquifers, 40% of them mapped. There's 1 political agreement, well known, the Guarani Aquifer Agreement, and many scientific arrangements. Asia came up with 129 transboundary aquifers identified, a few of them mapped, and I'm sure this is going to be updated again after this conference. There are no political agreements, or there were not at that time, and some scientific arrangements. Finally, in Europe, there were 226 TBAs identified, some of them mapped, but really the focus in Europe is on the groundwater bodies following the water directly from Europe. There's 1 well-known political agreement also, the Genovese Aquifer, but there are many scientific arrangements. Now, I like to show this because this will be included in the chapter I mentioned earlier, data and information that are required for the assessment and management of transboundary aquifers. Clearly, the first on the blue, hydrogeology, physiography, and climate, is all related to physical sciences, which we as hydrogeologists are very used to use, so to speak. You go anything from aquifer, defining aquifer geometry, recharge and discharge mechanisms, lithology, and what else. However, as we have learned over the time with ISARM, is that in fact, that is not enough. We need other data and information sets. For instance, environmental data. We require groundwater quality, potential pollution sources, and many of the transboundary aquifers we have seen actually contain groundwater-dependent ecosystem between the 2 jurisdictions or more. So that is a very important part of set of information. But that is not all. If you go on the right-hand side with different colors, the socioeconomical set of information is of extreme importance, particularly when it comes to sharing the management of the transboundary aquifer, such as population, and sometimes refugees or displacement of people going within from one camp to the other, one country to the other, and groundwater use, who is using what, abstraction, etc. So this is a very important set of information. And finally, and by far not the least, some of the lessons we have learned is that the information on legal and institutional frameworks are extremely important. And I'm very happy to say that I've heard already yesterday in one of the sessions that some countries are already considering transboundary legal frameworks and how to deal with them. So here we need information on ownership of groundwater, the groundwater extraction control, enforcement of legislations or not, etc. So this is, I believe, a very important set of information that we need for assessment and management of transboundary aquifers. Right. I'll quickly tell you about the TWAP program. The objective is to provide a description of the conditions of the main transboundary aquifers globally to prioritize identified TBAs for investment and bring these issues and concerns to the TBAs to the attention of policymakers, international financial institutions, and of course, scientific community. TWAP has produced a map in 2009, then in 2012, and again in 2015, showing the information available at those times on the occurrence and extent of transboundary aquifers. And we are now that when you combine TWAP with ISARM and with the project GRETA, for instance, well, guidelines for the assessment of TBAs have been produced, and an update global map is to be released this week. Actually, it has been already, and look for it. It's very interesting changes that we can see there. And the GRETA project was designed to enhance cooperation on water security, transboundary and water use conflicts, and improve overall environmental sustainability. This stands, the GRETA stands for Governance of Groundwater Resources in Transboundary Assessment. It has 3 phases from 2013 to 16, again 16 to 19, and it's still going on today until 2022. The first phase had an in-depth assessment of transboundary aquifers in Central America, while on the second phase is focusing on governance, development of frameworks, tools for the and the multi-country cooperation mechanisms in Southern Africa. Finally, the third phase is interlink institutional and technical capacity, consolidate regional cooperation, and evidence-based decision-making capacity for quality protection and monitoring. I would like to mention that all these works, they require a very high degree of the hydro diplomacy. And clearly, if you look at the UNESCO TBA projects over the years, in Central America, Ocotepeque, Citala Aquifer, in Africa, in South America, the Guarani Aquifer, many in South Africa, Eastern Europe, and Central Asia. Clearly, hydrodiplomacy supports and promotes cooperative agreements and increasing institutional capacity of neighboring states to reduce conflict and increase cooperation over shared waters. I kindly invite you to look at this nice book produced in 2016 by UNESCO and partners, where you can see about and read more about these projects and the degree of hydrodiplomacy. Right, the role of ISARM, my third team here. Well, I know you had a whole session today, so these were designed to have 17 global goals to reflect really global challenges. And they were based on 3 pillars of the sustainable development, that is, enhance economic growth, advance environmental objectives, and improve social conditions. I am here referring particularly to Goal 6, clean water and sanitation, and more importantly, its target 6.5, which is the water resources management. This one has 2 indicators, the degree of IWRM, 651, and then 652, the proportion of transboundary basins /aquifer area with an operational arrangement for water cooperation. These 2 books have been published, one in 2018 and the second one just this year, with the results of ISARM, of the Sustainable Development Goals. Now, the ISARM principles clearly have contributed to these targets by focusing on the implementation of this indicator and the cooperation management of transboundary waters. The second reporting cycle, 129 countries out of 152 reported progress. One interesting thing that came up is that both the United Nations and UNESCO have launched the SDG G6 Acceleration Framework Initiative to deliver fast results at an increased scale for SDG 6 TBA cooperation is among the initiative's priorities. Well, let me summarize this and tell you that clearly, after 2 decades of ISARM, it continues to inspire countries to make progress on TBAs, characterization, assessment, and modeling, to develop TBAs governance and shared management, to engage in nations in sharing TBAs, and promoting the United Nations draft articles as guidance. I believe that there are still challenges to resolve: lack of investment, lack of knowledge in data harmonization, transboundary agreements and arrangement. And yesterday we heard from our colleague Shami Puri what the future will bring. So I won't say more about that. Brief, ISARM is ensuring the continuation of global transboundary TBAs networks. And both UNESCO and the International Association of Hydrogeologists have clearly solidified ISARM and created a long-term legacy. I will, on behalf of my colleagues, Alicia and Christina, I thank you for your attention.
Dear Alfonso, thank you very much for that wonderful presentation, very enlightening on ISARM and its history, and very useful for us here in this session. Any questions, please put them in the Q&A section, and then we'll pick them up during the discussion part. So now I would like to introduce the second speaker, Ni hao, Han Saicheng. It's great to have you on board. Dr. Han, he will speak on a topic called Asian Transboundary Aquifer for Sustainable Development. And Saicheng Han is also a very, very experienced hydrogeologist. He obtained his doctoral degree from China University a very long time ago, and he has many, many years of experience leading and planning management for national hydrogeological and environmental geology in China. He has, over the decades, worked a lot on groundwater resource evaluation. He's done numerical simulation, environmental geological assessment, looked at groundwater in mining areas, and also for geothermal resources exploration. I think that's a very timely topic these days. So, Dr. Han, I'd like to give you the floor, and please go ahead with your presentation.
Yeah. Hello, everyone. Well, nice to see all of this. Ladies and gentlemen, I'm in Beijing in the evening. I was in the China Geological Survey and retired, but also a professor in the China University of Geoscience. I will take a presentation. Yeah. Yeah, the paper of the title is of Asian Transboundary Aquifers Sustainable Development. You know, transboundary aquifers have several vertical water upon which the large of number peoples. So in Asia, as you know, a complex relation occurring in the area, both upstream recharge area and downstream regions. The international boundaries and effect manager TBA is particularly important for the region. The TBA has received less attention for the political makers, scientists, and the local communities to the hidden diver and nature and difficult to conduct the hydrological investigation across the international boundaries. China Geological Survey has operated if the UNESCO HP, IIH, and other partners complete the Asian hydrogeological map. This map is the base map for update the inventory of Asian transboundary aquifers. We make this map in about 20 years ago, and we devised the groundwater system in Asia, about 11 groundwater systems, and also 36 subsystems, including the semi-Henry's upland, North China Plain, Toptic semi-Hemis area in Iran and the Mino Peninsula. So this is 11 groundwater system in Asia, both North, East, and Middle Asia. The transboundary aquifers indication begins as follows in the 20th beginning, just follow the UNESCO's IIP. The first version about the innovation is about in 1906, just a simple inventory. According to 20 years, they have in 28 and 2011 and 2015 versions. So we have indicated the 129 aquifers in total TPS in Asia. Is about 9 million kilometers, cover about 20% of inter-regions. Across global TPS events, a total 38 countries identified to have international share aquifers in terms of number of TPAs. Central Asia is the most, especially in Uzbekistan, and follow is China, Russia, Pakistan, and Kyrgyzstan, Mongolia, and Iran. This is the new map about the Asian transboundary maps, and will be changed and update more. In the East Asia, especially in the China's boundary, we have the details, scientific research, and according to China to Russia, China to Korea, China with Mongolia's boundary, also in Kazakhstan's aquifers, this Yilik rivers, Heilongjiang, Amur rivers, and in the Mongolia's temperatures around the China. This is most details research about the China Geological Survey. In Southeast Asia, the Vietnam, Cambodia, Laos, and also have the Mekong River have some importance transboundary aquifers. In the Mekong River data, there's the both of the surface water and the groundwater also. The North Asia, about around India, is the north boundaries between Pakistan and Mankala. the Central Asia have another project by UNESCO with their countries have their map, and we follow them. The West Asia also in this area. Groundwater qualities in TBAs shows very characters depend on the climate, geological material, and human activities. Some TBAs shows some groundwater qualities problems. Similar country in Asia also show in the water lake. In Asia, several regions have laws established with the legal and institutional framework cooperation. With the effort, many countries in Asia recognize the importance of their TBAs and their need to neighbor in dealing with TBAs governments country. Example like China, we have the hydrogeological cooperation with the Russia's hydrogeologist in the northeast boundary aquifers. We also have scientific agreement with Kazakhstan with the Ili Rivers basin. There's also bias for the Ili Rivers surface water, also in groundwater. As you know, the Mediterranean snow water are increase depend on the climate change with water. So the quantity, both the surface water and the groundwater, are increased in recent years. So we cooperation with the water use and both groundwater and the surface water with Kazakhstan's government with the agreements for exchange the data about the water. We will need more established to create the neighborhood countries to agreement, and scientists also in politics. Consequently, sustainable and equally management of TBA resource in Asia require increase in the intergovernmental agencies, politics, scientists, and local communities to reach the concept of effective cooperation. For academic and technical preparation, more attention to pay establish the link, because hydrogeologic knowledge to groundwater management practice based on the immediately understanding the TBA basins and the impact of the water cycle. Thank you for attention. There another time, may I have another about 94th Congress will held in China, and there's a video. Please take us.
Thank you very much, Dr. Han.
Yeah.
Yeah. Were you were down there with your presentation?
Yeah. We just a video.
Oh, you want to show a video? Okay, thank you.
Yeah. Okay.
Dr. Han, I think there's no sound on the video.
With your activeness, share your ideas, experiences, knowledge. I believe this Congress China will be a great success. See you next year.
Thank you for attention. Hello.
Dr. Han, so there was a nice presentation of the groundwater resources in Asia and showing a number of good maps. That's important to know the resource before we can actually start to manage the resource. And it seems like we will be meeting in Wuhan next year. So I'd like to introduce the next speaker, which is Dr. Raya Stefan. Ryan, she's an international consultant with expertise in water law in particularly. And she will be speaking on a topic named Contributions to Agenda 2030 and to the Climate Change Regime, a Transboundary Aquifers Perspective. So that's spot on to the overall title of this session. Raya, please, the floor is yours.
Thank you, Max, for the introduction. Let me start by sharing my screen. Yes, this is the bottom. Okay, can you see now my screen?
Yes, we can see that. Thank you.
Okay, thank you. Actually, much has been said this morning in the panel on the contribution of ISARM and transboundary aquifers to the SDGs and by Alfonso in the first presentation, so it will make my task easier. I wanted to share with you my presentation with the following outline. I'll give some introductory word, and then I will see how global agendas what consideration they give to water and groundwater and indirectly transboundary aquifers, and then I will look at the perspective from the cooperation on transboundary aquifers in a few conclusive words. So, I mean, we all know here, and we are here because of that the groundwater represents 97% of the available fresh water on Earth, and that most of it is in transboundary aquifers. So it shows how much transboundary aquifers are important for realizing all the objectives that we might have at the global level for the ensuring access to water for the human population. Okay, I move this here. So the global agendas I am going to look at are Agenda 2030, SDG 6, but also others SDGs, and the climate change framework, which has given little consideration to water resources, despite these two hashtags that I have mentioned here that were created by water organizations under past COPs. The last one, Water for Climate, was at the COP26 in Glasgow. And the climate change framework has given little consideration to water, but there are still direct or indirect effects under this framework. And the objective of my talk is to, like I already said, is to analyze the water, groundwater in the global agenda, so SDGs and climate change, and to compare with the requirements under international water law. To start with the considerations under the global agendas, just to remind that Agenda 23 has set a general objective to ensure a social and economic development and that it is interrelated. This social and economic development is interrelated with the sustainable management of natural resources. This is at the beginning, introduction to Agenda 23. And it also mentions the determinations of the countries to conserve and sustainably use freshwater resources. So SDG 6.5, as it has been mentioned here, is about the implementation of IWRM at all levels, including through transboundary cooperation, with the specific indicator related to cooperation. I will not insist on this. Much has been said by people who are even more knowledgeable than me on this topic. But under Goal 6, which is about ensuring availability and sustainable management of water and sanitation for all, we have other targets: achieve universal and equitable access to safe and affordable drinking water for all, improve water quality, ensure sustainable withdrawals and supply of fresh water to address water scarcity, and protect and restore water-related ecosystems, including various ecosystems, but also aquifers and lakes. So here we understand that transboundary aquifers are these issues are very important in transboundary aquifers, and that these goals cannot be achieved without any cooperation within the country, because if we want to improve water quality, it has to be on all sides of the border. Same if we want to ensure a sustainable withdrawal, it has to be on all sides of the water. So there has to be minimum cooperation and agreements between the countries sharing an aquifer. Under the SDGs, we have other goals that are interrelated to water. I mentioned them here. Goal 1, ending poverty. Goal 2, reaching food security. Goal 3, reaching healthy lives. We've seen with this pandemic the importance of access to clean and potable drinking water. Goal 8, sustainable economic growth. We cannot have an economic growth without a proper access to water resources and a proper management of water resources. The protection of territorial ecosystems. Ecosystems rely a lot on water and groundwater. Same for combating desertification or halting biodiversity loss. Water resources here are very important. And as most of the water on Earth are in transboundary aquifers, these goals are also, transboundary aquifers are also important for reaching these goals. Now, on the climate change framework, under the UNFCCC, under the convention, water is mentioned under adaptation, and the countries are required to develop and elaborate appropriate plans for adaptation for water resources and for the protection and rehabilitation of areas, particularly in Africa, affected by drought and desertification, as well as floods. So here we have the mention of water resources only under adaptation. There are other items, of course, under this Article 4 that you can check in the Climate Change Convention. And water resources, we have the two aspects that are the, let's say, the most visible one of climate change, with more and more drought are seeing important floods. In her talk this morning, Carol reminded us that even in the countries of the Arabian Gulf, they have faced floods, which is rather unusual, but because there were heavy rains in a very short while. Adaptation has been defined by the Paris Agreement as the global goal and challenge at all levels, so going from local to subnational, national, regional, and international, which shows that this adaptation has to be considered at all these levels, but also at the international, regional. So through cooperation on water resources, and adaptation has been considered as important for the protection of people, livelihoods, and ecosystems. There are various elements that the parties should strengthen for enhancing action on adaptation, including sharing information, strengthening institutional arrangements, strengthening scientific knowledge, assisting developing countries, and improving the effectiveness and durability of adaptive agriculture. So all these elements are things that we have been hearing about regarding transboundary aquifers and transboundary aquifers, cooperation on transboundary aquifers. The sharing data and information has been is one key issue, and perhaps the first thing to do when we want to cooperate on a transboundary aquifer or transboundary water body in general. There has to be strong institutions. The scientific knowledge has to improve. So what I mean to say here is all what we are required to improve or to create cooperation on transboundary aquifers. The climate change requires this adaptation to climate change requires the same thing, and it's an additional element in the building cooperation on transboundary aquifers. The climate change institutional instruments have mentioned water indirectly, and we've seen in the Anforso's presentation, I guess, the importance of ecosystems. So the Climate Change Framework Convention, the Paris Agreement, and the Glasgow Climate Pact, all of them mention ecosystems and acknowledge the importance to protect, conserve, and restore ecosystems to deliver crucial services. So they act as sinks and reservoirs of greenhouse gases. They reduce the vulnerability to climate change impacts. They support livelihoods, including for indigenous people and local communities. And we all know that ecosystems have a great reliance on water resources and groundwater in particular, and they can be in transboundary aquifers, and the ecosystem itself can be transboundary. Another indirect mention of water or indirect effect on water resources is ensuring food security. So the Climate Change Convention and the Paris Agreement both state that all adaptation measures to climate change should not threaten food production, and it is important to safeguard food security. It's a fundamental priority according to the Paris Agreement. Vulnerabilities of food production system to the adverse impacts of climate change is recognized, and adaptation and resilience, like I said, should not threaten food production. So food production is also, I mean, closely linked, water is closely linked to food production or vice versa. But also these two global agendas, the SDGs and the climate change framework, are both underlain by the human rights approach. The Paris Agreement and the Glasgow Climate Pact mentioned that all actions to address climate change should respect, promote, and consider the obligations on that the states have on human rights. And they mention in particular the right to health and the right to development. But the human rights are also mentioned in general. And the SDGs give a clear reference to the Universal Declaration of Human Rights and to the international human rights treaties. They say the SDGs mention that they seek to realize the human rights of all, and there's a clear commitment from the SDGs to the human right to safe drinking water and sanitation. And if I can remind you here that the human right to safe drinking water and sanitation has been recognized as the essential right to realize all the other human rights. So it is like as if it is the basic human rights which will allow the states to reach and realize all the human rights, and indirectly the SDGs, and creating an adaptation to climate change. And we address the human rights to safe drinking water through proper cooperation of the states on their shared water resources and transboundary aquifers. So I have reached my conclusion, just to remind the central role of water and the central role of transboundary aquifers in the global agendas. And so cooperation in between the riparian countries of transboundary aquifers is important to reach these goals, and the commitment the countries have taken for the realization of the SDGs and for any action under the climate change framework. The transboundary aquifers are governed by international water law, being a shared water resource between two or more countries. International water law, one of the objectives of international water law is to regulate the use of water resources shared by 2 or more countries, and to determine a state's entitlement to the benefits of the water course or the transboundary aquifers, and to establish requirements for states' behavior while developing the resource. Cooperation on transboundary aquifers is important beyond the management of the water resource itself. It is important for achieving SDGs, as ending poverty, reaching food security, reaching economic growth, and protection of ecosystems. It is important to adapt to climate change. Groundwater plays a specific role compared to surface water and beyond dimensions in the climate change agreements, because groundwater, when it is properly managed and not under stress, provides a unique buffer during extended dry period, and aquifers can store water in a time of climate change. Thank you for your attention.
Many thanks, Dr. Raya, for that excellent presentation, highlighting how groundwater is very important for a whole range of SDGs underpinning society and development, and also for highlighting the important aspects of human rights, which is often neglected. And I think it's important to stress that. Now, we would like to turn to a very interesting case study in the border of Niger and Nigeria. We will listen to a presentation labeled Groundwater Discharge to the River Niger from a large paleochannel estimated from subsurface geophysics in the Lulemeden Basin. And the presenter is Mr. Abdou Momoni Rabilou from University of Niamey. He's a PhD candidate there. So please, Abdou, the floor is yours. Abdou, I think you have to unmute yourself. You have to find the mute button.
Ok, c'est fait. Je suis en train de partager ma présentation. Bonjour tout le monde, je m'appelle Abdou Mohamed Rabilou, je suis doctorant à l'Université de Niamey. Ma présentation porte sur groundwater discharge to the river Niger from a large paleochannel estimated from subsurface geophysical elemental basin, frontière Niger-Nigeria. Ça, à noter que le Niger est un pays semi-aride avec des précipitations limitées par la courte saison de pluie. Elle est confrontée depuis plus de 5 décennies à une insécurité alimentaire chronique et à la pauvreté. À cet effet, pour atténuer ces effets, le recours aux nappes d'eau souterraines peu profondes est facilement accessible dans les vallées alluviales. Pour l'irrigation, s'avère une alternative crédible. Et cela répond aux des objectifs de développement durable, à savoir objectifs ODD 2 et ODD 6. À noter que le Niger dispose d'un réseau hydrographique constitué essentiellement de cours d'eau temporaires, à l'exception du fleuve Niger. Mais ces bassins hydrologiques du fleuve Niger disposent d'importantes ressources en eau souterraine contenues dans les formations géologiques du bassin des Simanda et dans les alluvions quaternaires des vallées fossiles. Ces ressources en eau contenues dans les alluvions sont généralement sous-exploitées et l'essentiel sont drainées par le fleuve Niger. L'objectif de ce travail est de quantifier l'eau souterraine drainée par ce fleuve Niger pendant la saison sèche à travers la formation quaternaire du Dalol Mori. À noter que le Dalol Mori est un le bassin de Dalol-Mori. Le bassin de Dalol-Mori le bassin de Dalol-Mori qui est ici est un affluent fossile du fleuve Niger. Il est limité naturellement par le Dalol Bosso à l'ouest, la Rima, qui est ce côté riva à l'est, est drainé par le fleuve Niger dans l'extrémité sud. Pour atteindre notre objectif, des campagnes géophysiques ont été réalisées, 21 sondages TDM et 21 sondages RMP.
عبد الله خلي بالك لو الافضل اطلع بالاستناد كله مره واحده ما تقطعهوش يعني ما تقطعش بس على اليوتيوب
37 transversal, 37 de Bana, Dengou, Tchuniga et un 37 longitudinal qui suit l'axe de la vallée. À noter que les sondages géophysiques TDM et RMP réalisés ont permis de déterminer l'épaisseur du remplissage quaternaire et les paramètres hydrodynamiques de l'aquifère. Des nivellements de précision ont été réalisés au niveau des piézomètres réalisés et un suivi piézométrique ont été initiés depuis 2017 au niveau de ces piézomètres. Et on a utilisé la loi de Darcy pour quantifier le pli qui est drainé par le fleuve Niger à travers les formations quaternaires. Pour mieux caractériser cette formation alluvionnaire, on a choisi certains forages qui sont localisés dans la zone pour faire des sondages de calibration. Ici, nous avons les forages de Bengou, la description lithologique des forages de Bengou, corrélée aux résultats des sondages RMP et TDM. Donc, les résultats nous montrent une succession de 4 terrains corrélables aux formations géologiques. Le premier terrain, qui est situé de 0 à 15 mètres, avec une résistivité de 60 à 70 mètres et une teneur en eau de 30%, est corrélable aux formations de sable fin en moyen, de quaternaire. Deuxième terrain, de 200 à 240 mètres de résistivité avec une teneur en eau de 25%, est corrélable aux formations de sable fin en moyen du continental hamadien. Et un terrain de faible résistivité de 13 à 20 mètres corrélable au grès argileux du continental hamadien. Et le quatrième terrain de 150 à 200 mètres de résistivité corrélable aux formations de grès du continental hamadien. Sur les 37 de Bana, les sondages TDM et RMP réalisés ont montré une situation de 4 terrains de résistivité différentes corrélables aux formations géologiques de la zone. Le premier terrain, qui est ici, le premier terrain de résistivité qui varie entre 30 et 40 mètres de résistivité, corrélable aux formations alluvionnaires, ici, avec une teneur en eau qui varie entre 20 et 30%. Un deuxième terrain très conducteur avec une teneur en eau très faible, corrélable aux formations de marnes du Paléocène-Éocène. Et le troisième terrain avec une teneur en eau importante qui varie entre 25 et 30%, avec une résistivité moyenne de 100 à 150 mètres de résistivité, corrélable aux formations de sable fin agrossiers du continental hamadien. Et les troisième terrain de grès argilés et le quatrième terrain révélé par le sondage TDM de grès du continental hamadien. Sur les 35 de Bangou, également, trois terrains ont été révélés par le sondage et deux formations aquifères. La première formation aquifère dans les alluvions et la deuxième formation aquifère dans les continentales hamadiennes. De même, sur les 35 de Tuniga, deux formations aquifères ont été révélées par la formation par les sondages RMP. La première formation dans la vallée avec une teneur en eau qui varie entre 20 et 30%, et dans les formations du grès argilé du continental hamadien, une teneur en eau qui varie entre moins de 5 à 15%. Ça, c'est la coupe transversale sur l'axe de la vallée qui montre la variation en teneur en eau des vallées par rapport aux formations du continental hamadien. Pour déterminer le gradient hydraulique de l'aquifère, la variation amont-aval a été utilisée. Donc, des Bana à Bangou, la variation amont-aval de la piézométrie a révélé un gradient hydraulique de 0,2 pour 1000, et de Bangou à Tuniga, la variation de piézométrie a donné un gradient hydraulique de 3 pour 1000. Dans l'objectif de voir, de mieux caractériser la dynamique des eaux souterraines et le processus de recherche dans cette nappe-là, un suivi a été réalisé depuis 2017, un suivi de la nappe. Cette figure nous montre les fluctuations au niveau des piézomètres réalisés. Et ces fluctuations montrent que la pluie est la principale source de recharge de la nappe dans cette zone, comme nous montre les coïncidences avec les pics de recharge avec la pluie locale. Donc, ici, nous avons les différents flux quantifiés au niveau des 35 de Bana. Un flux de 1000 m3 par jour a été évalué et 1200 m3 par jour à la section de Bangou et 2000 m3 par jour à la section de Tuniga. La différence constatée entre le flux ici à la section de Bana et le flux à la section de Tuniga pourrait être liée aux incertitudes au niveau des paramètres de calcul. Et la différence au niveau entre le flux quantifié ici à la section de Tuniga et les deux autres flux quantifiés dans les sections en amont pourrait être due aux apports régionaux de l'aquifère. En conclusion, les TDM et RMP ont permis de mieux caractériser la géométrie de l'aquifère et les propriétés hydrodynamiques de la nappe libre dans la basse vallée du Dalal Mouri, et le pli environnemental évalué de 4,10 puissance 5 m3 par an contribue effectivement au l'écoulement du fleuve pendant le temps d'étiage. Une partie de ce flux pourrait être effectivement utilisée pour l'irrigation. Merci de votre attention.
Thank you, Mr. Abdu, for that interesting presentation from Nishir River area. And I get really interested to take a walk along your Paleochannel. It would be very, very exciting to see that site. And it's very good to see how important groundwork is being made, because I think we need to know our resources much better than we do today. So I'd like to introduce then the final speaker who will speak live, so to speak. We have a video presentation later on. And I wonder if we have Stefano Borci with us. I hope so. Stefano will speak on behalf of Elena Quadri on transboundary groundwater in international law.
Matt, I was informed that Stefano is not yet connected, so I would ask the technician of UNESCO to please move forward to the video of the next presenter. And if Stefano joins afterwards, he will be able to present. Thank you.
Okay, then we will look forward to a pre-recorded video, and that is presented by Bendris Gilali, and the topic is integrated management of the cross-border affair of the Dodain Valley. What is the role of hydrodiplomacy?
Bonjour. Dans le cadre de cette communication qui ne doit pas dépasser les 3 minutes selon les organisateurs, il est question pour nous de discuter la pertinence des concepts de l'hydrodiplomatie en tant qu'une nouvelle forme de gouvernance au regard d'une gestion intégrée de l'eau de l'aquifère de la vallée du Jourdain. Alors, je commence par localiser la zone d'étude et comme vous voyez sur la carte, la vallée du Jourdain se situe entre le lac Tibériade au nord et la mer Morte au sud. L'aquifère en question a une capacité totale de 335 millions de mètres cubes, ce qui dénote de son importance capitale. Concernant la gestion et l'utilisation de l'eau de cette zone, il faut faire les constats suivants. L'eau souterraine constitue une source importante de l'approvisionnement en eau dans cette zone aride. Ensuite, l'eau est otage de la politique. Ça veut dire qu'elle est fortement imprégnée par le conflit territorial qui oppose Israël aux Palestiniens. Ensuite, l'accès à l'eau est fortement inégalitaire et reste marqué par la caractéristique éternelle, l'eau est l'ami du puissant. Enfin, l'eau de l'aquifère fait l'objet d'une gestion minière préjudiciable à la ressource. Face à cette situation, la gestion intégrée, participative et décentralisée des eaux de l'aquifère constitue la solution adéquate. L'hydrodiplomatie est le moyen de parvenir à cette gestion. Il s'agit donc de répondre à la question ainsi formulée. Dans quelle mesure l'hydrodiplomatie permet-elle d'assurer une gestion intégrée de l'eau de l'aquifère? Il s'agit au fait de discuter la pertinence de l'hydrodiplomatie en tant que concept de nouvelle gouvernance de l'eau en vue d'un partage équitable et d'une gestion rationnelle de la ressource. La démarche à suivre consiste donc à libérer l'eau des conflits territoriaux en vue d'instaurer une gestion basée sur le dialogue et la concertation pour faire face aux défis du changement climatique qui menace les pays, tout niveau de développement confondu. J'arrive à la fin. Merci de votre attention.
Okay, thank you very much to Bendris Gilali, who sent this message in a pre-recorded video. It seems like Stefano Bucci has not yet joined, so he might come on board, but that means that we have ample time for discussions. And I'd like to ask all the presenters to be part of that discussion, as well as questions from the audience, which is also very much welcome. And you can use the Q&A button on your screen to send questions, and we will pick them up. So maybe to start off, there's been a set of very interesting presentations highlighting different aspects of transboundary groundwater aquifers, and particularly in many cases how it relates to the SDGs. If we go to the questions in the Q&A session, one question here is about the sharing the hydrogeological and water use data to the neighboring countries when you have a transboundary aquifer. And the question is particularly pointing to developing countries, but I think it's an aspect which is of great interest. Now we're discussing a resource which is often neglected because we cannot see it properly. We know it's there, but it's often overlooked. And how do we manage this, and how do we monitor the resource? And how do we share data on this? Maybe we could ask Raya, if you would like to address this question a little bit. I know from the legal aspects, this is a very important topic. And equally on looking at surface waters as well as groundwaters, there's a need of communication between the stakeholders that are to benefit from the resource, and how can we actually support this, and what's the status at the moment? I was thinking that you have probably looked into this over the years in the work you're doing. Raya, would you like to address this question about how to share data?
I can give an answer from the legal perspective, as you say, and perhaps then there can be some technical scientific answers. From the legal perspective, under the UN ILC draft articles on the law of transboundary aquifers, sharing regular exchange of data and information is the first implementation of the general obligation to cooperate. So it shows that it is let's say the basic step for initiating cooperation, and I think it applies to both surface waters and groundwaters, but certainly it is a more important and more crucial in the case of aquifers, as it is in a resource that we don't see. So the need of the data is very important. And from the few cases of transboundary aquifers where we have an agreement, most of them have started with the exchange of data. If I can mention the case of the Northwestern Sahara Aquifer System, the countries have initiated, built the consultation mechanism after creating a joint database and a joint model for the aquifer, which is shared between Algeria, Tunisia, and Libya. And their idea was to maintain this database and to continually update it and update the model. So that's why they created this consultation mechanism where the countries regularly give their data to have the continuous idea about the evolution of the aquifer. But as mentioned in the previous session, I think this is also a complicated issue because often with international projects, some databases and work on joint monitoring, on creating data, etc., is done, and the problem is then to sustaining this effort. There is the problem of capacities, financial resources, etc., that needs to be addressed, because we have also often seen, we have seen success stories, but we have seen also projects where this effort could not continue after the ending of the project. Thank you.
Thank you, Ryan. Maybe I could ask Alfonso if he would like to add something to this dimension.
Yes, thank you, Mr. Erickson. I'm not so sure if I understand 100% of the question. And if I do, I would like to actually separate the question in two parts in order to provide a reply, point of view, rather. So, yeah, data, and I can read, but barely read the questions on the screen. It's so small font, but I can see that, in fact, and this goes all together, not only one particular area. I can see it in two ways. One is how may people on both sides of a transboundary aquifer agree upon the cooperation, or the level of cooperation, and even more, the collaboration of sharing the same goals. That's one part. And the second part is much easier for me because I'm a technical guy. I'm a hydrogeologist. And I can tell you in a rather easy way what are the limits of the operational critical levels of a transboundary aquifer when you're having issues between the two sides. Particularly, how do you calculate the limits of influence, as somebody wrote in one of the questions? I will begin with the second one because this is what I know more and I have experience on it. This is not easy, but it's straightforward. And I was happy to see the PhD student for Niamey addressing technical questions. And this is something that we need to do. And then later on, I come on to the first part. So yeah, it is not straightforward, but you have techniques and methods to share data so that you understand what are the critical hotspots, so to speak, of a transboundary aquifer being shared and with the potential conflict. And by defining these hotspots, you can use a series of techniques that exist, such as, well, fingerprinting, isotope, defining groundwater flow systems, defining what are the areas of influence of wells. So if you're pumping one well, two wells, three wells, etc., you can define the hotspots on both sides of the border. Right now, the border, don't forget, is a fictitious border. The aquifer doesn't know that border, so the aquifer moves back and forth. And when man gets into it, then you get the pumping, and we can evaluate the pumping, conal depression. We can evaluate groundwater flow system. We can know the scales of time and space. When you have that in man, which is knowledge, then you are able to somehow come to the first part that I mentioned. How may you share the aquifer in ways of managing so that it keeps, what is written in the draft articles, equitable use, keep it up for sustainable development, and so on. That part is a little bit more difficult to me because it requires a lot of hydrodiplomacy. It requires a lot of cooperation, and people have to agree on that. But the technical part, I will say, and I stop there. The technical part exists. There are methods, there are ways of what data you require, how may you use the data to define the hotspots, and so on. I'm not so sure if I replied to the question exactly, but that's what I understood from the question. Thank you.
No, thank you, Alfonso. I mean, it's great. What we're discussing here is actually, it has several layers, as you say. I mean, first we need to know the resource, and how do we do that? It's not as easy to monitor and assess groundwater resources as surface water in many cases. But once we know the resource, and also if we know that it's a transboundary groundwater resource, of course, we should ideally have some kind of agreement or management ideas on how to use this resource for the best purposes. So there are many aspects to that. Actually, Alfonso, I'd like to read a quote from your abstract, if you may allow me. It says in your abstract, filling the gaps between science and policy due to a lack of understanding of groundwater processes by politicians and stakeholders remains a major endeavor. I think this is a very important sentence that you added there. I mean, how do we bridge the gaps between science and policy? And yes. How do we make politicians and stakeholders to understand the importance of groundwater and understand the value and the potential of groundwater to actually sustain societies and underpin development, and as we say here in this session, the SDGs, how can we actually use the groundwater resource to support the SDGs? I don't know if you want to comment on that one.
Yeah, well, Mats, thank you so much for bringing that up. Actually, it's timely, because now that I have your attention and the attention of the public, I'd like to let you know that exactly the question the sentence that you read from me is exactly what we're going to try to address on a 1-hour panel discussion right after this session. So we have a panel number 2, the gaps in how do we transfer knowledge or science into policy. And so I won't say more, because I already know the answers to some of the panelists that I will be sharing, by the way. But yes, indeed, it is a gap. Over 20 years of ISARM, we have learned that this is something that is a whole void. We speak and we know scientists, but we don't transfer that. And somehow we have to learn how to speak to politicians and water managers and other people that perhaps do not understand our jargon. So this is something that we're going to discuss, and I kindly invite you to come join us. I invited 4 panelists, high-level panelists that will be joining us later today in about an hour or so. So I won't say more, Matt, so thank you so much for underlying that sentence of mine. Thank you.
Thank you, Alfonso. And I note that Dr. Stefano Burci have now joined us. Very, very, very much welcome. So we managed to have a little bit of discussion, and I think we can come back to that discussion in a while. But now I would then like to give the floor to Stefano. And Stefano, who will speak on behalf of Elena Quadri on the topic transboundary groundwater in international law. So another interesting topic, and Stefano is also very long expertise. From many years, 25 years, Stefano, you served at FAO, so you have a long expertise from that area, and of course, in relation to ISARM and the transboundary groundwater programs. I understand that you now are the chair of the International Association for Water Law, AIDA. So please, Stefano, we look forward to your presentation. Stefano, are you with us?
I believe Stefano's having like some technical issues. So maybe we can proceed with one more question until he reconnects.
I think he needs to reconnect probably. That's often the case. So meanwhile, maybe I'm curious, having done research in the field myself in East Africa and knowing that when you work on the ground, you learn a lot of things. I'm addressing now to Abdu a question here. Now I can see Stefano is coming up here.
My God, this is becoming...
Abdu, before...
this is becoming an exercise.
Okay, so we have Stefano with us. All right, let's go with Stefano.
Oh, my God, this presentation is
Stefano, would you like us to share the presentation on your behalf, maybe to give you some more bandwidth?
Yes, perhaps that's better. Yes.
Sure. Okay, so you can proceed. You can proceed with your presentation. We're sharing in a second.
Okay. Now this is good morning to one and all. I'm very sorry for all the troubles I'm having, with this, with my internet connection. But anyway, let's give it a try. So this is a presentation developed by Professor Elena Quadri of the University for Foreigners of Perugia in Italy. And it's a presentation that gives sort of an overview of how transboundary groundwater is dealt in by international law. Next slide, please. Now, as a background, the basic, some basic considerations. Unsustainable freshwater exploitation patterns, water pollution, and climate variability are contributing to the growing strategic importance of groundwater, which represents 97% of total freshwater on the planet, stocked in geological formations known as aquifers, a number of which are common to 2 or more states and therefore are of a transboundary nature. Now, this presentation and the research that's behind it illustrates essentially how the international law addresses transboundary groundwater in particular, and the recognition of groundwater in agreements among states, but also in customary international water law and other, legal or paralegal instruments. The next slide, please. Now, by the mid-20th century, groundwater had attracted attention, but marginal. This attention has been marginal relative to the main focus of water treaties and, I would say, of customary international water law, which was mostly, on surface water resources, rivers, lakes, and at best basins. Now, the full recognition of the link between surface water and groundwater and, attention to groundwater in particular has emerged in several treaties made in the last decades, in parallel to the growing awareness of the importance of preserving groundwater, a vital resource from overexploitation and from pollution. The next slide, please. Now, the chief international instrument that addresses the transboundary groundwater and transboundary aquifers, legal instruments which is of a non-binding nature, is the draft articles on the law of transboundary aquifers, originated from the work of the United Nations International Law Commission between 2003 and 2008, assisted by, may I add, UNESCO, a group of experts, under the lead of UNESCO, IHP, and was eventually crafted and appended as a United Nations General Assembly resolution number 63124 of December 2008 as a non-binding instrument. So, this is important, to bear in mind that the draft articles are a non-binding, legally non-binding instrument, but they serve as a guidance for states in the negotiation of agreements and other instruments, legal instruments, on transboundary aquifers. Next slide, please. The predecessor to the UN draft articles on the law of transboundary aquifers, that is the 1997 UN Watercourses Convention, had left a gap in regard to groundwater. So it is with a view to filling that gap that the International Law Commission of the United Nations was tasked by the General Assembly to fill that gap. Now, the draft articles are the result of intense collaboration between legal experts and scientists over a period of 5 years, inspired and driven, there you have it, by the IHP, the UNESCO International Hydrological Program. Now, the draft is largely patterned, or at least follows the same conceptual scheme and arrangement as the 1997 UN Convention, the sister, if you like, Convention on the Law of the Non-Navigational Uses of International Watercourses, with adjustments due to the nature of aquifers and to their vulnerability, the particular vulnerability of aquifers and groundwater to pollution and to over-exploitation and eventual exhaustion. Now, although, as I said and repeat, the draft articles as a whole is not a binding legal instrument per se, still, the draft articles carry some substantive procedural and environment protection norms that constitute customary international law and as a result are legally binding universally. So there are a number of core norms, core principles that reflect customary international law and are therefore binding, even though the draft articles as an instrument are not binding, as such. Next slide, please. Now, the draft articles carry two key substantive rules. The first, acknowledging the right of states to the equitable and reasonable utilization of transboundary aquifers, obligating also states to maximize the long-term benefits from the use of such aquifers, which is something that's specific to to groundwater. And the second such rule inhibits states from causing significant cross-border harm. The procedural norms concern monitoring, the exchange of data and information, and the duty of states to provide advance notice of planned measures that can have a cross-border impact. This is because they are customary international water law, they are binding on all states universally.
Matt, I believe Stefano lost his connection again, so maybe you can just give him 1 minute more in case he can reconnect.
Thank you. I also lost connection, so I was out of the picture for a while. But now I can see Stefano joining.
Unbelievable. My God, I've never had so many problems. I apologize. This is terrible. Anyway, if we can carry on, where were we with the presentation? I was at slide, there it is. The key substantive principles. Okay, where's my presentation? Hello?
Yes, it's there. It's already on the screen, Stefan.
Because I can't see it. For some reason, I don't see it. Boop. Okay. My God. Okay, thanks. Very good. Okay. Now, can I have the next one, Mahmoud, please? Okay. So now, the environment protection norms in the draft articles have a particular importance in view of, as I said, the vulnerability of aquifers. Now, in particular, states are to take all appropriate measures to protect and preserve the ecosystems within or dependent upon a transboundary aquifer and to ensure adequate recharge and discharge flows. This is one. Another is pollution prevention and minimization obligations that are of particular importance to the natural recharge of aquifers and that reflect, the same kind of environment protection concerns. And taken altogether, these norms aim to respect and reflect the entire ecosystem, groundwater, and the ecosystem that is dependent on groundwater, and to safeguard the ecosystem support function of transboundary aquifers. The next one, please. The principle of the limited sovereignty of states is also cast in the draft articles. And in accordance to this principle, the principle of sovereignty is qualified by general norms of international law, and in particular by those that are posited in the draft. And in good substance, the sovereignty of states is there, but it's qualified by the principle of equitable and reasonable use of aquifers, by the duty not to cause significant cross-border harm, and by the other norms that are posited in the draft. The next slide, please. Now, there are a number, a handful agreements that have been made by states regarding transboundary aquifers. So there are very many known transboundary aquifers, but only a handful specific arrangements, legal arrangements, treaties, agreements, or whatever, regarding a very small number of aquifers. Just quickly, they are the agreement on the Genovese aquifer in Europe, renegotiated in 2007, the agreement on the Nubian sandstone aquifer system shared by Chad, Egypt, Libya, and the Sudan, an agreement for the establishment of a consultative arrangement for the Northwestern Sahara aquifer system, shared by Algeria, Libya, and Tunisia. The next one, please. An agreement, an MOU technically, made by Mali, Niger, and Nigeria for the establishment of a consultative arrangement for the Yulemeden aquifer system, which is not in force yet, to be replaced by a subsequent MOU made by a large number of states that encompass also the connected Taude-Tanesruft aquifer system, that together with the Yulemeden. But this second agreement, MOU, is not yet in effect. An agreement on the Guarani aquifer, which is very well known, made in 2010 by Argentina, Brazil, Paraguay, and Uruguay. And lastly, an agreement on the Al-Sagaldisi aquifer, made in 2015 by Jordan and Saudi Arabia. Next one, please. In addition, now, there are a number of other, mostly, lower level arrangements that a number of which, are, at least the ones that are known are indicated on this slide, ranging from an MOU between British Columbia, the province of British Columbia in Canada, and Washington State in the United States about the Abbotsford-Sumas aquifer, and a number of others, all the way to a statement of intent made in 2019 by stakeholders from El Salvador and Honduras, committing to cooperation in respect of a small, teeny, but very important locally transboundary aquifer known as the Ocotepeque-Sitala. So there are a number of agreements among sovereign states, but also a handful of lower level instruments, arrangements made by different units of government at subnational levels of government. The next one slide, please. And also relevant in this context are the model provisions on transboundary groundwater that were framed in the framework of the UN ECE Convention on the Protection and Use of Transboundary Watercourses and International Lakes of 1992, that in 2012 crafted these model provisions that are in the nature of a soft law instrument for the guidance of the parties to the convention with specific regard to transboundary groundwater and with a view to facilitating the implementation of the convention in that particular regard. Now, they are based largely on the draft articles that serve again, as a beacon of inspiration. And the model provisions carry norms of customary international water law that, are binding universally. But in itself, the instrument, the model provisions, is a non-binding non-binding instrument. So the next one, please. And I believe this is the conclusions. Yes. Now, state practice in the matter of cooperation regarding transboundary aquifers is scanty. Specific mention and references to groundwater have begun appearing only recently, and the relevant international law is under development and evolving. Now, there is a need for a legally binding instrument of universal application. But for the time being, and until that time comes, the UN draft articles on the law of transboundary aquifers remain the most authoritative reference, albeit non-binding, but authoritative reference for states on a global scale. Thank you very much. And I believe, yes, this is the end of the presentation by Dr. Quadri. Thank you for your attention and especially for your patience with this rather fledgling internet connection of mine.
Thank you very much, Stefano, for highlighting these legal aspects on transboundary water aquifers. And it's quite mind-blowing that there's only 7 formal agreements in place regulating the areas when there are 342, according to your information, transboundary aquifers worldwide. So it really shows that, as you mentioned, the awareness of the importance of transboundary aquifers only emerged not so long ago, and we're in the midst of the rising awareness, I guess. So we're sort of globally learning about the resource, and we're also learning and trying to find the pathway forward on how to actually manage and use this resource in a sustainable way. So if I now look at the Q&A, because now we have a few minutes left to continue the discussions, and I actually the question that was put earlier is now erased from my screen for some reason, but I have an idea a little bit about they were focusing quite a bit on similar topics, and it relates to we discussed just before you took the floor, Stefano, that we highlighted the important void between science and policy when it comes to managing this resource. So how do we use the science and the knowledge about the resource to actually underpin decision and policy making related to this section? And when we move forward in this constant learning about the resource and learning on how to use it, I'd like to ask the panel, what do you think what are the main bottlenecks where we stand now in terms of managing the resource? Is it on the technical side? Do we need to know the resource better? I'm sure that's huge gaps on knowing how much water do we have in the different aquifers and how it's varying over time and so on. Or is the main bottleneck actually on the governance and management side? How to use it, I guess, regardless if there's an agreement in place or not, these resources are being used. So maybe, Stefano, maybe you want to address that question as a first speaker?
Yeah, sure. Yes, to my mind, it's a mix of both. where the knowledge, the knowledge of the physical, the physical knowledge of the aquifer is, of the aquifer and of groundwater, or should I say, the incomplete physical knowledge of the aquifer and groundwater has frequently generally been lamented, as one of the key problems to putting in place serious, the sustainable management and development plans for the aquifer, and not only domestically, but in particular, in a transboundary context. But then, once that knowledge gap is filled, and there are very many examples of and efforts being conducted in order to fill that gap, then comes in the governance dimension, which is a very I would say challenging, tricky business, because there are so many, there are different, sensitivities involved. And I'm talking in a cross-border, in a transboundary context setting. There are different, different legal systems, different sensitivities, different priorities, different policy perspectives, different groups of stakeholders, across the borders, that influence, the decision-making processes, that militate against, quick solutions, quick governance solutions. At the same time, we have examples, also recent, from recent history, of ways to, or attempts to, overcome all these these obstacles. Think for instance, a good example of this, to my mind, is the Northwestern Sahara Aquifer System, which is a huge aquifer, which has been, studied and, for very many years, very many decades by the countries. They have developed a very sophisticated aquifer model, but then, the issue was then to institutionalize cooperation, to set up, some kind of consultation mechanism, which has been created, is in place, and now this consultation mechanism has the tools, the instruments, the mathematical model, the simulations and everything to make tough decisions. So the governance arrangements, the knowledge of the aquifer is there, all the way to a very sophisticated model. The governance arrangements, or at least the noyau, the essentials, the basics of a governance arrangement are in place, a consultation mechanism. But now the tough,
Thank you, Stefano. I think that's great. I mean, you're highlighted the importance of having a communication between the science and policy decision making, where I think it's steps moving between each other, and we're coming close to the end of the section. I just want to.
I'm sorry, I was taking too much.
Finally, before coming to an end, I'd just like to ask Han-Sei Chang, what's your? You know everything about the groundwater aquifers in Asia and China, particularly. How is the interaction between science and policy there, and what are the sort of, how do policy and decision makers know the resource?
Yeah, very nice to about this question. I will take an example between China and Kazakhstan. We have aquifers in the Ili River, both the surface water and groundwater. Under the Department of Groundwater in the government, between the two countries, Kazakhstan and China, the Xinjiang region's water department have a scientific data exchange. Both the river flow and the groundwater. And I have an agreement for the river, because China is the upstream. the water come from the Tianshan Mountains. Because climate change, the snow metrics are increased for many years. So the water from China to Kazakhstan are also increased in the recent 10 years. So we have agreement is make the balance and to keep the flow from China to Afghanistan for support the Afghanistan's economic situation. That's an example for you.
Thank you.
Right.
Thank you. Thank you. That's another interesting example. So I think my conclusion is that we are in the midst of a very large learning process about the resource and how to manage it. And I think I would like to thank all the presenters for the contributions. It's been extremely wonderful to listen to all of you and learn about the experiences and from many different aspects. So, and sorry to those of you who did not get to speak in the discussion part, but I think we ran out of time now. And thank you for the patience with a little bit of the technology issues also. So I'll hand back now to Rita at UNESCO. Thank you very much.
Yeah, thank you.
So thank you, everyone. Thank you, all the speakers, for the very interesting presentations. And thank you, Mads, for this very efficient time management. We will now terminate this session. I would welcome everyone to join us again at 1:30 Paris time for panel number 2 on the science and policy interface in the TBA's context. Hope to see you all soon. Thank you so much.
Thank you.
Thank you. Thank you. Au revoir.
Au revoir. Au revoir.
Technicien UNESCO, are you available? Are you there? Anybody like attending from technical team, please?
That's going to be very busy session. I know. Oh yeah, we are about 8, 7 speakers. And most of them are
No?
far.
Okay, thank you.